We have two examples here, and they both have the instructions to just simply solve the system of equations. So in part A, we have three equations. In my first equations, I have an x, y, and z. In my second one, we have a y and a z. And the third one, we simply have z equals -2. So if I need to solve this system of equation, they have already told me what one variable equals. Z equals -2. So how does that help me get x and y? Well, in the second equation, I know what z equals. I only have one unknown here of y. So I'm going to take this equation here and solve for y. So I have y plus 3 times z, which is -2, and that equals 3. So we have y minus 6 equals 3. Let's add our 6 over, and we get y equals 9. So now I have solved for two unknowns. So now I know my y and my z. Now I can use this top equation here to get my x. So that top equation is now x plus 2 times y, which is 9, minus z, which is -2, and that's going to equal 6. So be careful here. Minus from my equation, and what I'm substituting in has a negative, so that's why we have a double negative here. So we got x plus 18, negative times negative makes that a +2. My like terms give me x plus 20 equals 6. Subtract our 20 over, and we have x equals -14. So more than likely in my math lab, it's just going to say x equals, you're typing in -14, y equals, you're typing in 9, and z equals, you're typing in -2. But for me, I like these as ordered pairs. And when I have ordered pairs with three variables, it's going to go x, comma y, comma z. So my final answer would be -14, comma 9, comma -2. And so again, this is x, then y, and then z. Now the process used in example A of using the value of the third variable to work back to the values of the other variables is called back substitution. So because I knew one, and then my next equation only had two variables, and I knew one of them, I can substitute in, find the next one, and now I had z and y, so I can plug that in and get that third one there. So that process is called back substitution.